This Zoom session is being brought to you by the Fractal Bullseye Bubble Water. All right. Oops. How did this happen? There we are. Much better. Okay, great. Right angle trigonometry. Finally, we're at chapter 4. And so finally, we'll get to the chapter which actually does what the title of the course is, and that is measuring triangles. Trigon, three-side measure. Okay, so we're measuring three-sided objects, triangles. Now, this one we'll talk about triangles with a 90-degree angle at one corner. This is so this is a right angle, 90 degrees at this corner. Now, okay, given a triangle, there will be 6 numbers characterizing it. The sides A, B, and C, and the angles alpha, beta, and gamma. In this case, gamma is 90 degrees. And it's traditional to use Greek letters for angles because the Greeks did a whole lot of work on it. So there we are. Okay, fine. So now, all right. Given that one of the rules of triangles is their angles add up to 180 degrees. And since this angle is 90 degrees, and you transpose, you get that, and each other and the other variable, you get the alpha is 90 degrees minus beta, and beta is 90 degrees minus alpha. So given one angle, you can get the other two. Well, given this one angle, you get a relation between the other two. And given beta, you get alpha. Given alpha, you get beta. Okay, fine. Now, this is a right triangle, so we have the right angle relations between the sides and the trig function. So, for example, A over C is sine alpha, and it's also cosine beta. B over C is cosine alpha and also sine beta. A over B is tangent alpha. B over A is tangent beta. And so from these, if you transpose the C in each of these, or the B or the A, you get that A equals B tan alpha from here, and also equals B divided by tan beta. You get that from here. From here, you get that A equals C sine alpha, and it's also C cosine beta. And B is, from here, you get that B is C cosine alpha and also C sine beta. Also from here that it's A tangent beta. From here that it's A divided by tangent beta. The A over divided by tangent alpha. From here, you can get, after a bit of algebra, that C equals A over sine alpha and A divided by cosine beta. C is also B over cosine alpha and also B over sine beta. So, okay. So here, what we get is that given an angle and a side, you can get some of the other sides. Of course, since it's the right triangle, we have the Pythagorean relation that a squared plus b squared equals c squared. Therefore, after some square roots and transpositions, c equals square root of a squared plus b squared, a equals square root of c squared minus b squared, and b equals square root of c squared minus a squared. That you can derive from here, the Pythagorean. And also, because A over B is tan alpha and B over A is tan beta, if you take arctangents, then alpha is arctangent A over B, and beta is arctan B over A. There may be some problems if we have right angle, if we have obtuse triangles. This is acute right angle, but okay, that wouldn't be a right triangle. Okay, so okay, basically in practice, given a right angle and 2 of the other numbers, a side and an angle, you can get the other sides and angles. For example, in this right triangle, the angle alpha is 35 degrees. The side B is 12.1 units. So what is beta? What is A? And what is C? Okay, first off, we can find beta easily enough. Since beta is 90 degrees minus alpha in this right angle triangle, then beta is 90 degrees minus 35 degrees, which is 55 degrees. Okay, that's the first number gotten. A over B equals tan alpha, so A equals B tan alpha. A equals B tan alpha. 12.1 tan 35 degrees, which is approximately 8.47. That's A. Now to find C from B over C. Okay, basically what you do is you try and use the quantities that are given. This angle alpha, this side B. B over C is cosine alpha. And after a bit of algebra, that's C equals B over cos alpha. That's 12.1 divided by cosine 35 degrees, which is approximately C is 14.8. So given these 2 numbers and this 90 degree, you can the other 3 numbers. And that'll be a fairly standard thing. later on. What we'll get is that given 3 of the numbers around a triangle, we'll usually have the other 3 numbers. The exception is when there's no triangle possible, or when you just get 3 angles, because that's not enough. You have 3 angles, you can really tell the ratios of the sides, but any similar triangle will have the same angles. We'll get to that later. Now, here we have alpha, 20 degrees, and A, 13.7. So we have a side and its opposite angle. What are the other 2 sides, B and C, and what is the angle beta? Okay, beta, the angle is easy enough, 90 degrees minus alpha. 90 minus 20 is 70 degrees. So now for B, well, okay, we know A and alpha. So we want to relate to B, A over B equals tangent alpha here. And after a couple of transpositions, you get the B equals A tangent over tangent alpha. That's 13.7 divided by tangent 20 degrees, which means that B is approximately 37.6. I suppose really I should have approximate equal signs rather than equal signs here. Also, this is only known, A is only given to 1 decimal place, so it makes sense to give B and C in terms of only 1 decimal place. Okay, now we have A and B, we want to find C. Well, A over C is sine alpha. So if we transpose the C and the sine alpha, you get the C equals A divided by sine alpha. That's 13.7 divided by sine of 20 degrees. So C is about 40.1. All right, now here we're given alpha is 42 degrees and C is 17.5. We're A and B and beta. Okay, beta as usual is the easy one. It'll be 90 degrees minus alpha. That's 90 degrees minus 42 degrees. That's 48 degrees is beta. Okay, great. Now, given A and alpha and C, to find A, alpha and C, find A, well, A over C equals sine alpha. So transpose the C. A equals C sine alpha at 17.5, sine 42 degrees. So A is about 11.7. Okay, B, given B, to find B and C, find B. Well, B over C equals cosine alpha. We know C and cosine and alpha. So transpose the C. B equals C cosine alpha at 17.5 cosine 42 degrees. So B is about 13.0. Not exactly, but close. Okay, now here we have a right triangle given 2 sides around the right angle. 3 and 4 for A and B. What's the hypotenuse C, and what are the 2 angles alpha and beta? Now for this one, we have 2 sides of a right triangle. We want to find the diagonal C. Well, C is root A squared plus B squared. All right, so we plug in 3 and 4. C equals root 3 squared plus 4 squared, which is root 25. 9 plus 16 is 25. Square root of 25 is 5. This is the 3, 4, 5 triangle. Now, okay, we're given A and B. To find alpha, well, A over B is tangent alpha here. So alpha is arctangent 3/4, which comes out to 36.87. Now here I use tan beta equals B over A, and that's tangent beta is 4/3, so arctan 4/3, about 51.13 degrees. I could have gotten it also by taking 90 degrees minus this alpha, 90 minus 36.87, and you should get 51.13. And you do, but I actually prefer to use what I like to call fresher ingredients. Rather than a derived quantity like alpha, let's start from the given quantities A and B. That's because when you calculate, errors tend to accumulate and so on. Well, all right. Now here we have a right triangle with the one side given and the hypotenuse given. A is 1, C is 3. What's B? What's alpha? And what's beta? Now, all right. A squared plus B squared equals C squared. If you transpose the A squared and take a square root, get B equals root of C squared minus A squared. So you plug in 3 in for C and 1 in for A. B equals root of 3 squared minus 1 squared. That's 9 minus 1 is 8. You can rewrite 8 as root 4 root 2. So B equals 2 root 2. That's the value of B. Now, all right, we're given A and C. We want to find these trig functions. Well, A over C is sine alpha. So taking arcsines, alpha is arcsine 1/3, which is approximately 19.47 degrees. Now, A and C are adjacent and a hypotenuse for beta. So cosine of beta is 1/3. So beta is arc cosine 1/3. and a push of a button will give you that B equals about 70.53 degrees. And again, you could have also calculated beta given alpha. 90 degrees minus 19.47 degrees is 70.53 degrees. But again, relying on A and B is relying on fresher ingredients. Oh, here's a cute one. This is a kind of a non-trivial word problem. Here we have two buildings. One is, here's a short skyscraper, and here's another skyscraper, 2,001 feet tall. From the base of this skyscraper, you look up to the top of the other one, and you have to crane your neck at an angle 35 degrees from the horizontal. It's called an angle of elevation. Now, if you ride the elevator up to the top and somehow climb up illegally onto the roof, and again, you look at the top of the other building, you have to crane your neck upwards by 15 degrees, an angle of elevation of 15 degrees. Okay, so here's some questions. So 35 degrees, 15 degrees, 2,001 feet. What is the distance between the two buildings? What is the height of the shorter building? And here's a similar height. If you draw horizontal, this should be a similar height, equal height. Call it h, same h as this. And this remainder is k. So specifically, what's the height of the second building? What's the distance between the two buildings? And along the way, we'll figure out how much taller the second building is. All right, now we have this right triangle. Well, let's see. We have this right triangle here. Right triangles, because these are skyscrapers set straight upwards. All right. I've never seen someone try to do a tilted skyscraper, though I assume the Millennium Tower is attempting to become that. Oh, right, and of course, the Leaning Tower of Pisa, another accident. But anyhow, this is a height of 2,001 feet. This is a distance of d feet. This is 35 degrees. And okay, so the trigonometric relation is that 2,001 feet over d equals tangent 35 degrees. Okay, so we have a first equation. After a couple of transpositions, d equals 2,001 feet divided by tangent of 35 degrees. So the distance between the two skyscrapers is about 2,857.7 feet. Now I add in this 0.7 with some reluctance, because our original data doesn't have it in tenths of feet, but I'll put it in just as an excessive caution. All right, now this distance k is, well, it plus h is 2,001 feet, so k is 2,001 feet minus h. And since we've just figured out, okay, that's k. And here we have a right triangle with sides k and d and an angle of 15 degrees. So tangent of 15 degrees equals k over d. All right, d we already know, 2857.7. Unfortunately, not entirely the freshest ingredient, but it'll do. It's been verified. And k is 2,001 feet minus h. We now have an equation involving h, and only h. Well, after a bit of algebra, we transpose 2857.7 over 2, and we transpose the h, transpose all that. Okay, after the bit of algebra, we get that h equals 2,001 feet minus 2857.7 times tan 15 degrees. Okay, so here you just do get your calculator, and out comes h is about 1,235.3 feet to the nearest tenth of a foot. Okay, so that's h. So great, we have it. They are 2,857.7 feet apart, and the shorter building is 1,235.3 feet high. All right.